Okay, welcome at this free video tutorial from Carbon Media. My name is Julius Horsthuis. Um, this is the website of Carbon Media, by the way. Check it out. It's carbonmedia.nl. And I'm going to talk a little bit about a technique called camera mapping and camera tracking. And it offers a great scala on very cool things that you can do with your camera motion, for instance stabilizing or even completely redefining the camera path, making a complete new camera basically from your shot. What we're going to do is basically we're going to track a very wobbly, shaky handheld shot in Buju, and then we're going to import that tracking data in 3D Studio Max and render out a new camera with it using camera mapping. This can be done also in other tracking software such as Synthesize or any tracking software really, and also any 3D package that offers camera mapping or perspective mapping, as it's called in, for instance, Maya. I'm going to import a sequence here. I just have to browse in it. It's in Buju. It's pretty straightforward. Import sequence, and I have a plate here. Okay, this was not shot intended for this purpose at all, but it really works well, especially because it's a simple scene with a basic flat wall and a flat floor, and what happens is the camera is moving upwards while really being very shaky and wobbly. This guy walks in his door and the camera keeps wobbling. It's just a handheld shot. Okay. First step to do in Buju is track features, and you can also do the camera solve simultaneously. All the basic settings will work for this one, so I'll just press start, and if you're familiar with Buju software, you know what it's going to do. It's going to basically find all these little points in the shot, and it will track them. First it's just doing a 2D solve, and then it solves the camera motion in 3D. I'm going to pause the video because this takes a little while to render. Okay, we're halfway through the 2D solve right now. You can actually see those yellow lines, and they are the path that the red dots have followed through time. So by these here in the foreground, you can actually see the camera is moving upwards. And also you can see by the fact that they're not perfectly nice straight lines and they go pretty wobbly, that the camera move itself is pretty wobbly. Okay, that first pass has finished now. As you can see, if I scrub through the timeline, you'll see the path of all those red dots that it has tracked. Now I'm going to do the 3D solve of the camera. Right now this is only just 2D data, and from the 2D data it can actually solve how the camera moved in space using parallax and basic math. So press camera solve, all frames, all the default settings here, start, and I'll just have to wait a little bit. This probably will go pretty fast, as you can see. We're at 30%. And the solve is complete. We're just gonna have to check if it did hold, and all the points, they seem to stick pretty good. This probably means I've got a good solve. If I press here on 3D, you can actually see the 3D camera path, and it's moving upwards like that. So this is actually what really happened. This is the wall that we've been seeing, and these are some points on the floor, and this is my camera, and the red line here is defining the path of the camera. Okay, well, next step to do is to export this to in this case export it to 3D Studio Max, which is also the default setting here, but if you're using Maya, then you can also, or some other package, you can also select those. For this purpose I will use Max. I'll give it a name, and as we come back we'll actually open the script, the MS script as it's called in Max. Okay, here we are in Max, and what you have to do in order to get this this Boujou data into Max is actually go to Max script and then run script. I'll navigate to the location where I saved the files, and there it is, and I'll open it. Okay, what we got here is basically the same thing we saw before in Boujou, and that is all these points and one camera. If I press play on this or scrub the timeline, we can also see the camera is moving like that. What I've also done in Boujou is actually aligned the ground floor plane to the X, Y plane in Max, so that your scene is upright, because it basically doesn't know you know, which is facing upwards, or if the camera is pointing upwards or sideways in the beginning. If I go here to views camera 1, then I can actually see, and this will probably not show that well because of the screen capture software, but if you would do this, you would actually see a very smooth camera, well, not very smooth because it's shaky, because it's the original camera path showing. If I press here, if I right click on this and I do show background, I can actually also see the background plate here in the viewport, so you can see which point corresponds to which bit. Okay, with that out of the way, we have to model some basic geometry, and I am assuming you are familiar with Max here, so I'll just quickly step through this, and you know, you have to refer to your manual in Max if you don't know how to do this, or your other software. What I'm going to model is a very basic plane for the ground plane, then another plane for the wall of the office building. We'll make a little cylinder. You can actually see quite well how this cylinder is defined here, of the revolving door, and then there's another little plane here that is this plane. You know, it's this little flat wall thing here. So we'll model those 4 objects, and I'll do it pretty quickly here. Okay. So now I've got the floor plane and the wall of the office building. I'm going to make a cylinder primitive, which is pretty much the same radius as this revolving door and the same height. Just get it into place here. Looks pretty good. My height is a bit too high, a bit lower, a little like that. I'll make a thin box for this plane here. I'm not sure how high it is. It's maybe best thing to check it out in looking at the background. Okay. It's a little bit higher. Okay. So here we can also see, and actually I have to be careful with this and show save frame. Okay. Select my cylinder, make it a bit higher, and we're good to go. So this basic geometry will, if my track is correct, will always align in every shot, every frame of the shot, and it works pretty good. So now what we do is we make a material that is actually a camera per pixel material. So I go to the material editor, right there. And I'll create a, well, we have a standard material which is good for this. Self-illumination is going to 100% because we don't want any shading or shadows from max default lights or anything. We just want every pixel to show as bright as it went in. In the diffuse slot I will select the bitmap, and I will actually select the same plate as we have before in Buju. So it's a sequence, it's a PNG sequence, and here we go. I've actually forgot one step, but that's okay because I press here on bitmap, and actually we need a camera map per pixel map in between those. So I select keep old map as submap, and what I've got now is I've got in my diffuse slot I've got a camera map per pixel with a camera slot and a texture slot, and in the texture slot is the bitmap that we have just imported, and in the camera I will have to select my camera, which is right there. It's called camera 1. It's a standard name from Buju. Okay, this is all good. I'm quickly gonna rename this camera to something a little bit more handy. We'll call it projection camera. And one thing I have to do obviously is apply that material to the geometry that we just built. Basically select everything. Also selecting the points here, but it won't really matter because they can't have a material. Okay, I'm pressed here, assign material to selection. Okay, if I now quickly render the scene, we have a problem, and that is that we see everything except one plane here. So maybe there's a problem with that plane. Maybe it wasn't high enough. Or another thing that might be the case is that it's actually facing the wrong way. See if that's the case. That was the case. We looked at the back side of the plane. Now we're looking at the front, which is good. And it's exactly what we need to do. And I think actually the plane location should be there in the front row of these little points here. Okay, well, if I was to render this, we would actually exactly get the same shot as went in. So that's pretty useless because we're actually looking through the projection camera still. The cool thing right now is if I actually move to a perspective viewport, and I'll go view perspective, and I will render from a little different, and let me just get rid of the background here, a different angle. We actually see what's going on here. I'm just zooming out so we can see very well. Okay, this looks funky. We're looking at exactly the same thing as we saw before, but right now we're looking from a different perspective. So basically what we've got is the camera acting as a beamer, beaming the shot onto the geometry, and also because now we can see outside of the frame of the beamer, we see some really strange distortion happening. We don't have to worry about this because we're not gonna see this, because we're not going to render from this perspective. We're going to render from something close to the original camera path, but not exactly the original camera path. There's another good thing to do, and that is sometimes the edges do get into view, especially with these shaky shots. One thing, so we will just see it a little bit less, is actually to go back to the material editor and go to texture, and in the mapping coordinates here I will do instead of tile or mirror, if I just press mirror, there's actually a problem because looking through our original camera, we can see that we see this strange kaleidoscope thing going on here. So what we need to do to fix that is press 0.5 in the offset and the tiling, both the U and the V. Exactly that those figures give the right result back. But now if we move out, go back to perspective here, move out a little bit, we actually see that we are mirrored here. So if for instance, if your top is a sky, and so you have a little bit more of your sky than you originally filmed, you're not going to notice it because it'll just mirror the same color. So that's pretty cool. Okay, well, let's just make a new camera and and see what we can do with it. One thing to which is handy is to go to frame 1 and then look through our projection camera again. So now I'm going to actually press P, which is the same thing as going views perspective, and I'll create a new camera at this very location by pressing Control C, which is a shortcut for a new camera. And something went wrong here. Let me just go back. Okay, I'm looking through the projection camera and press P and a new camera. Here you can see the new camera exactly at the same point as the original shaky camera. This camera I will call View Cam, because it's the camera I'm going to look through. The other camera is basically acting as a beamer or a projector. I don't like target cameras, I like free cameras, so I'll make a free camera of it. And I will create a keyframe at frame 1, and I'll slide all the way back to the end frame, and I'll just loosely put the camera in the same location as the projector camera. It also moved a bit down, so I'll rotate it as well. Something like that. Don't have to be exact here, that's the cool thing. Okay, so now we got a really smooth motion like this. We do have to be careful again, because this camera is, the original camera is only moving up at frame, what is it? Frame 50. So actually just move my first keyframe to frame 50, and from there we will smoothly move up. Okay, well, this looks cool in the viewport and looks very smooth, but will it also render? Yes, it will, which I will demonstrate now by actually pressing render. And I'll make the entire time segment. I'll give it a name here. Just okay, I already have some. Make a new name called 6-axis test. And I'll press render. Hold on. Okay, while I was rendering, I realized I made a mistake. There's a really strange thing going on with Buju and Max, and the way they work together with the through the script. It has caused me many headaches, but I know how to solve it. I don't know why this is, but for some reason. I'm in a material editor here, and this is the bitmap with the shot in. This start frame defaults to frame 0, and actually when you start rendering you will see an offset in the projected image and the frame number of the camera that is projecting it, which is causing more wobble than originally went in, which is really weird. This is fixable by offsetting the start frame to frame 1. This shouldn't happen, I think, because Buju is scripted in a way that it should actually work directly when you get it into Max, but for some reason this does happen. So if you have the same problem, time start frame 1 instead of frame 0. Now we're good to go to render. I do want to save this. Okay, here we are at frame 55 of the render. This is the frame where the camera starts moving upwards. Already we can see here, because this is actually where the shot becomes really shaky. We can see here, if you look at the revolving door here, these points are really very well stuck into place. It doesn't move at all. And if you look here at the borders, for instance, they do move. These are the borders where the mirroring comes in. If you look at this trash can here, it will differ quite a lot from frame to frame. This is basically the proof that the original shot is shaky here, but that this method is basically solid. Okay, so here we are in After Effects. Just looking at the render. I just imported the PNG sequence that we just rendered, and let me just make this a little bit smaller. Here we can see the render. I'll see if I can cache this. Okay, here's the final shot. As you can see, it's very stable. I hope this plays well enough. But I've got on the tech blog, I've got an example of the final result of the film. As we can see, we do get the mirrored edges here into view quite a lot. There's a couple of workarounds around it. One most obvious one is to actually zoom in a little bit and crop them off. This obviously does lose you lose some field of view and some image resolution. And there's another way which is quite difficult to do, but I wrote a script, Mac script, that automates it for you, and that is it basically it doesn't mirror the edges at all. It actually creates a lot of cameras with offset timing, and also they're all basically projection cameras, and they all have an offset in timing, and also the frames that they project are offset in time, so they match with their initial offset. And if one camera loses the left hand side of the frame, for instance, some other camera of those 20 or 30 cameras that you can create with the script will actually at that moment have filmed that particular bit into view, so, and it will also match. So that's actually a really cool way to overcome this problem. I'll probably post that Mac script online for you guys to try it out. I'm not a great scripter, so maybe someone else is there to actually to make it a little bit better. Also, you don't have to follow the original camera path. You can also make a camera that actually, for instance, dollies in. It also really works very well with this shot. Just slightly dollying in a little bit, and you can really just because everything's mapped onto the geometry, you don't get strange distortions. Unless, for instance, if this guy would be walking into shot, you would see some strange distortions because you don't have geometry for this guy. But as long as you're close enough to the original camera position of the beamer, you don't notice the distortion. If you would stray too far away from it, you would notice it. But the cool thing with this technique, it doesn't just smooth out the rotation unevenness of the original shot. It also smooths out the translation. For instance, if you're filming in a car, you're filming outside of the car, you get lots of bumps in the road. The camera physically moves upwards and downwards. You can't correct that with traditional stabilizing or 2D stabilizing techniques such as you find in After Effects or in other similar programs. It actually smooths out the bump completely because you can because you remap your new camera position. So this concludes this video tutorial. I hope you enjoyed it. My name is Julius Rosthaus from crbonmedia.nl.